This video is on environmental index using factor analysis for assessing the impacts of a proposed project at a given location. Several genetic steps are associated with the development of numerical indices or classification of environmental quality or pollution potential of human activities. Identification of key factors is the first step. Key factor can be used as indicator of environmental quality, susceptibility to pollution, or the pollution potential of the source type. It should be done by the collective professional judgment of knowledgeable individuals through organized procedures such as Delphi approach. In the second step, relative importance weights or ranking of the identified factors in order of importance are assigned. Delphi approach is used to achieve this step. The third step is scaling, establishment, and factor evaluation. For the development of scaling and factor evaluation, several approaches has been used like linear scaling or categorization used on the range of data, letter or number assignments, designating data categories, etc., with the help of collective professional judgment of individuals knowledgeable in the area related to environmental media or pollution source. So consider preparation of an air pollution index. Air pollution are a result of a combined effect of several pollutants like suspended particulate matter, SOx, NOx, carbon monoxide, etc. The magnitude of air pollution is difficult to assess on the basis of concentration of the individual pollutants alone, but the goal can be achieved by applying certain indices. The kind and number of pollutants for calculating the indices can be selected depending upon their predominance in the ambient air. Pollution index should indicate the gross level of pollution with reference to the standard limits of the individual pollutants. It should be easy to understand and should include the major air pollutants. So this is national ambient air quality standards. You can see the pollutants, for example, of sulfur dioxide. The concentration in the ambient air in case of industrial, residential, rural and other area, the 24 hours time weighted average is 80 microgram per meter cube. So this is the maximum limit, permissible limit for the concentration of sulfur dioxide in the ambient air of industrial, residential, or rural or other areas except ecological sensitive areas. Likewise, for nitrogen dioxide, it is also 80 microgram per meter cube. For PM10 is 100 microgram per meter cube. PM2.5 is 60 microgram per meter cube. Accordingly, this is the example of air quality index. So based on the air quality index, the categories of good, satisfactory, moderately polluted are likewise. So you can see for 0 to 50 air quality index value, it will be the good. Accordingly, the individual pollutants index number and with respect to the category are given here. We will make a video how to prepare air quality index later. So overall, standards are predefined. As you know, that ambient quality standards are there. Ranking is performed across various parameters based on predefined standards. Based on overall ranking score, alternatives are ranked. So based on this environmental index method, environmental performance index is developed to rank countries in their progress toward mitigating climate change, improving environmental health, and protecting ecosystem vitality. Environmental Performance Index EPI provides a data-driven tool to track countries' progress towards meeting United Nations Sustainable Development Goal and other international policy targets. EPI integrates data on 58 performance indicators grouped into 11 environmental issue categories, 3 main policy objectives, as we know, the climate change, ecosystem vitality, and environmental health, and one overall EPI score for each country. In 2020-24, EPI scores 180 countries. For easy to interrupt, EPI transforms scores ranging from 100 to 0, and accordingly rank is given. EPI rank highlights leaders and laggards in different aspects of environmental performance and provides practical guidance for countries that aspire to move towards sustainable future. So overall, EPI rankings indicate which countries are best addressing the world's most critical environmental challenges. This is 2024 EPI framework. At the center of the framework, there are three policy objects: environmental health, climate change, and ecosystem vitality. EPI gives a weight of 25% to environmental health, 30% to climate change, and 45% to ecosystem vitality. Environmental health measures the impacts of environmental pollution on human well-being. Ecosystem vitality assesses the sustainability of rural resource use and the conservation of natural ecosystem, and climate change focuses on tracking countries' emission of climate pollution. So out of the 11 environmental issue categories, environmental health includes 4 issue categories: air quality, sanitation and drinking, heavy metals, and waste management. Ecosystem vitality includes 6 issues, that is ecosystem biodiversity and habitat, forest, fisheries, air pollution, agriculture and water resources. And climate change include only one issue of climate change mitigation. So as we know, there are 58 performance indicators. So if you consider air quality under environmental health, we can see that ambient ppm 2.5 for human sources given 6.5% of overall weightage. So accordingly, for sanitation and drinking water, you can say that unsafe water is given 3% of weightage. So likewise, you can see the performance 58 performance indicators weightage with in this EPI. So this is the map of 180 countries based on EPI ranking 2024, and out of the 180 countries, India's position is 176. So we can conclude here that for conduction of EIA studies, various methodologies are available for assessing the impacts of proposed project. So the methodologies need to be selected and used as per the project requirements and conditions, time constraints, and available data and resources. So such methodology each methodology has its own benefit and limitation, which should be considered during selection process, and it is not necessary for every method to be applicable in all situations. So with the end of this video, I complete 8 parts of EIA methodologies: so ad hoc method, checklist method, matrix method, network method, overlay method, cost benefit analysis, simulation method, and this environmental index using factor analysis. So considering these all 8 methodologies, you can say that this is not necessary that all methods or every method is applicable all situations. Every method has its own benefit and limitations. So before selection of method, we should consider which method is applicable here, and this selection is based on the project requirements, time constraints, and this. So for this particular factor analysis, you can read this reference. Thank you for watching this video.